I'm going to do a couple of examples of testing a claim about two independent means. Well, here's the first example. I'm going to give a chart. This is the way they give the homework examples. I'm going to talk about cats and skunks. And we're going to call cats the first population mean, skunks the second population mean, sample size, sample mean, sample standard deviation. For the cats, 31 is the sample size, a mean height of 3.2 with a standard deviation of 0.6. For the skunks, a sample size of 28, a mean height of 3.1, and a standard deviation of 0.5. Now here's the question. With alpha, significance equals 0.05, test the claim. Skunks and cats have the same height. As usual, there are three parts to this. Number one is the setup. And because we're saying that it says they're the same, that they're equal to each other, we're going to go with the is part of this chart. So I'm reading along the bottom row. Now again, this was for proportions, but now we're talking about two means. We're going along the bottom row there. So the setup goes like this. The claim is that the two means are equal. Mu1 is equal to mu2. The opposite of the claim is that mu1 is not equal to mu2. The null hypothesis is that they're equal, and this is from the original claim. And the alternate hypothesis is that they're not equal. Mu1 is not equal to mu2, and that makes for a two-tailed test. On the calculator, which is the second part of this, on the calculator, I'm going to turn it on, and I'm going to stat tests to samp t-test. Okay, so I'm going to write that down. Test stat tests to samp t-test, which I think is number 4 on that menu. And I'm going to enter on the calculator the data that we're given. I have the date on this paper on the side here, so I'm going to erase this. So on the calculator, I'm using the stats feature of this. X1 bar is the first sample mean, which I gave as 3.2 for the cat's mean. The SX1 is the first sample standard deviation, which is 0.6. The N1 is the first sample size, which is 31. Careful, the calculator may not ask for the data in the same order it's given to you. X bar 2 is the second sample mean, which was 3.1 for the skunks. The sample standard deviation for the skunks was given as 0.5, and the sample size for the skunks was given as 28. Arrow down, we want to match the form of the alternate hypothesis, which was not equal. Pooled is always no. If in class I'd give a 20-minute math major discussion about that, but I'll spare you. And when you hit calculate, you get the t value, the test statistic, and the p value. So there, the t is equal to 0.6977, which is what the homework will want as what they call the test statistic. And the all-important p value is this 0.4882. 0.4882, that's the p value. We're ready to draw our conclusion. Since P equals 0.4882 is greater than alpha is 0.05, that means that we fail to reject H null. And going back to the setup, it was from the original claim. So if I look at the wording chart for the conclusion, fail to reject H null from original claim. Fail to reject H null from original claim. There is not sufficient evidence to reject the claim. Not sufficient evidence to reject the claim that skunks and cats have the same height. Okay, I wanted to do one more example of this. And I'm going to give you another chart of some data to start this out. So this time, we're going to talk about ants and gnats. So here's another example. Ants and gnats, two of my favorite bugs. So we'll call ants mu1, gnats mu2, and the same thing, I'm going to give you a sample size for each, a mean for each, and a standard deviation for each. For the ants, there were 35 ants with a mean weight of 0.72 with a standard deviation of 0.05. There are 37 gnats with a mean weight of 0.63 with a standard deviation of 0.04. Now here's the question. With alpha equals 0.05, test the claim that ants weigh more than gnats. Ants weigh more than gnats. So again, there's going to be the setup, the calculator, and then the conclusion. So for the setup, since the claim says ants weigh more than, I'm going to look at the more than row in the setup, which is the first row here. And when I do that, the claim is that mu1 is more than mu2. The opposite, mu1 less than or equal to mu2. The null hypothesis, mu1 and mu2 are equal, which is not from the original. And the alternate hypothesis is mu1 greater than mu2, which makes for a right tail test. The calculator. So number 2, the calculator. I'm going to stat tests number 4 2samp t-test. Stat tests number 4 2samp t-test using the stats option, and now I'm going to enter the data. So the first mean is the mean weight of the ants, which is 0.72. The first standard deviation is 0.05. The first sample size is 35. 35. Then the second mean, which is the mean weight of the gnats, is 0.63. The standard deviation for the gnats is 0.04, and the sample size for the gnats is 37. We want to match the form. Whoops, wrong button. Whoops, sorry. Get out of there. Stat, I don't know what happened. Stat tests, 2samp t-test. Go back. Okay, there we are. N2 was 37. We want to match the form of the alternate hypothesis, which is greater than. Hit enter. Pooled is always no. And when I hit calculate, I get, oh, I didn't write that down. Okay, let me go back for a second because I wanted to write those numbers down. Okay. Tests, 2samp t-test. I just wanted to write that down. So x1 was 0.72, sx1 was 0.05, n1 was 35, x2 was 63.63, sx2 was 0.04, n2 was 37. We wanted to, for the mu1, we wanted to highlight the greater than mu2. Pool is always no, and when I do calculate, I get the t value and the p value. The t, the test statistic, about 8.41 to 2 decimal places. So t is 8.41, that's the test statistic. This is saying if the null hypothesis is true, then this data is 8 standard deviations off the mean. And that's reflected in a very low p-value. I'm going to say about 2.76 e minus 12. 2.76 e minus 12. Remember, that's the calculator's way of giving scientific notation. 2.76 times 10 to the negative 12. That negative 12 there is going to put 11 zeros in front of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 7, 6. You don't have to write that out. Just know that that's a very tiny value close to 0. Now that we have that, we're ready to draw our conclusion. So step 3, the conclusion. Since p is that very tiny number, 2.76 times 10 to the minus 12, is less than alpha, that means we reject H null. And going back to the original setup, H null was not from the original claim. And if we look to the wording chart for the conclusion, reject H null, not from original, reject H null, not from original, the sample data support the claim, is the conclusion. Sample data support the claim.